Good day, viewers. Welcome to Science Spectrum with Don. This is the second part of the first lecture in ratio, proportions, and variations. Now we are in the middle of something. That was this question. We are to share 780 among three persons, P, Q, and R in the ratio 1/4 to 1/3 to 1/2. And of course, I had to multiply each of these. Just to clear the fraction, I had to multiply each of these by the LCM of the denominators, or so to speak, the consequent. And of course, this boils down to ratio 3:4 to 6. Now, the first person share, which is P's share, it would be the first ratio over the sum of the ratios times the total amount to be shared. And of course, I'm interested in knowing how many 13s I will get in 78. So just look for the multiples of 13, multiples of 13, multiples of 13, multiples of 13, and of course the list could just go on and on and on. So to get these multiples is a straightforward thing. Just keep adding 13. This is 26. So when you add 13 to 26, you get 9. This is 39. When you add 13, this is a 12. This is a 5. So when you add 13, this is 5, and this is 6, so you get 65. And when you add 13 to this becomes 8, this becomes a 7. And of course, it's exactly where you had wanted to. So I do know that 78 divided by 13 would go 6 times. So I could get 6 13 in 78. So this is 6. And of course, I'm left with 3. I'm left with 3 times 60, that's an error. 3 times 6, that's 18. And of course, taking this 1 0 in front. So P's share will be 118 error. Now, let's see what Q's share will be. Person Q and R's share will be. So Q's share would be, this boils down to be ratio 3, okay, by 12. If I do that, by 12, by 12, by 12. So this is 4. This is ratio 3:4 to 6. So this is 4 out of the sum of everything, which is just 13, sum of the ratios, times the overall amount to be shared, that's 718 error. Because I know I could get 6 13 in 78. I'm left with 60 here, so this becomes 4 times 60, and of course 6 times 4 is 24. This is 24. I'll stick in the 1 0 in front. That is Q's share. Then the last but not the least, R share. As in its R share would be 6 out of the sum of the ratios, which is 13, times 780, which is the right amount to be shared. And of course, I know I will get 6 out of this, so this becomes 6 times 60 in error, and this is 3. So 6 times 6 is 36, and I'm sticking a 0 in front. And of course, you could verify this. You could sum 180, 240, and 360, and of course, see if we get 780. That's how we verify if this is the correct solution. This is 0, this is 12. And of course, on 12 plus 6 gives this 18. Carry 1 over, this is 4. 4 plus 3, that becomes 6. And of course, it's very correct. And of course, we could do more of the examples. Now, another example is this. Let's take, for instance, that ratio x to y is equal to ratio 3:4, just is the same as ratio 3:4, and ratio y to z is just the same or equal to ratio 6:11. So the first question is this: we're looking for what the ratio of x to y to z would be. But if you look at this closely, solution. If you look at this closely, you figure out that y repeats itself here. There's a y here, and y is 4 here, in the first pair of ratio, but y is 6 in the second pair of ratio, and of course I have to make them equal. So what do I simply do? I will divide y in the first ratio by y in the second ratio, and of course this becomes 2/3. 2 in 2, 2 in 4, 2, 2 in 6 is 3. So this 2/3 I could multiply by 6, or just multiply by the pair of ratio, by the pair of the second ratio. The goal is I will always want y to be the same in both pairs of ratios. So given the ratio y to z, which is 6 to 11, I could multiply. I will multiply 6 by 2/3, and of course I'll get a 4, just like the value of y in the first pair of ratio, and also multiply 11 by 2/3. So y would be 6, I'll multiply that by 2/3, this is ratio y to z, then 11 by 2/3. This is a 2, this becomes a 4, just like we had in the first pair of ratio, and of course 11 times 2, that's 22/3. So ratio x to y to z would be x is a 3 here, and of course y is now the same 4 in both pairs of ratio, and of course the z is 22/3. Alright, or 22/3. But this is over 1 and this is over 1. But I have to clear this fraction. So I multiply by the LCM, and of course the LCM of 1, 1 and 3 is 12. I mean it's 3 rather, so the LCM is 3. So I can multiply this by 3, and once I do that, 3 times 3 over 1, so 4 over 1 times 3, then 3 times 22/3, this 3 cancels. Of course I have a 9, I have a 12, and I have a 22. And of course no common factor can divide these 3 terms all together. So I'll now say therefore, ratio x to y to z, given those two pair of ratio, would be is ratio 9 to 12 to 22. And of course there are other questions in ratio we would likely do in a couple of moments. Alright, let's take for instance another example. If b is 3a and a is 4c, find ratio b to c. This is another question. So what we'll simply do is this, b is 3a, but I know a is 4c, so I could replace 4c for a here in this first equation. So b becomes 3, a is 4c, that's into 4c, so b becomes 12c. Now we could divide both sides by c. Of course, since I'm looking for the ratio b to c, which is the same as b over c, so c will cancel out, so I have ratio b over c is 12 over 1. So we could say therefore ratio b to c is 12 to 1. And of course that is the answer. And of course there are many more of these questions and ratios we could address. But for the sake of time, I need to wrap it up here. Like, share and subscribe for more content if you're new to this channel. Thank you.